everyone, my name is Nova Butte. My project for this summer was on analyzing the metrics of the OSDR website and the datasets. So for a little bit of background, what is OSDR? OSDR stands for Open Science Data Repository, and it's basically a website with a bunch of datasets that come from studies that GeneLab and ALSDA did, and anyone can go there and download that data and analyze the datasets. So it's part of open science, and the aim of open science is to make science more accessible, more understandable, remove barriers to entry so that more people can get interested in science, so that people don't always think that science is like a big mysterious black box or anything. So my project was to quickly and reliably determine what datasets people were interacting with the most on the OSDR website, and then what the statistics for the OSDR datasets themselves were. So the spreadsheets that have the data on who's using the website, what datasets are they downloading, those spreadsheets are hundreds of thousands of rows long. So obviously it takes a long time to count all that up. So my job was to write code to automate that process to make it quicker, easier, more reliable, nothing gets miscounted. So that was my job. And I used Jupyter Notebook and Conda Python to do this. I used NumPy, Pandas to organize the data, and then I used Matplotlib and Plotly to make the graphs. So part one of my project was analyzing the metrics for the OSDR website. Who's using the website, what datasets are they downloading, all that stuff. So for part one, I received the monthly datasets in the form of a big long CSV file or a comma-separated value file. And those files showed everyone who visited the website over the course of a month. And they had columns for the date and time of each visit, the IP address of the person who visited, the specific page of the website that they visited. And so I read the file into many Python lists with a list for each column's data. And then I analyzed the data and made some graphs. And just a note, these graphs are from February 2021 specifically, only that month. So I also wanted to show a bit of the code from not just the graphs. I wanted to show a snippet of the code that I wrote, because a lot of people think like coding is like a mysterious black box and like they don't necessarily understand it. So I wanted to explain some of the process that I did to show, I suppose, the more human side of coding. So for each row of the CSV file, I'd split it on the commas to get the data for each column. And I didn't realize until I looked at the data that some of the data had too many commas in it. So it would be a sentence or a link to a specific page of the website, and that link had a comma in it, and that was causing the data to split into too many columns. So this was interesting for me because normally I just go left to right, read in each column, and bing, bang, boom, I'm done with it. But this time it was interesting for me because I had to figure out how to switch my perspective. I had to look at the last column of the data, and that column always had a single number in it or an integer in it. And so I had to find that data type and use that to figure out where this whole mess of columns was ending. And then there were two columns in a row that were split too much. So the second of those split columns had either 0 or 1 extra comma, depending on what specifically was written in it. And so from there, I was able to work backwards and piece together the columns the way they were supposed to be. So this was a fun process for me because I got to test my coding skills in a real world situation outside of the classroom. So after I solved that problem, I made some graphs, and here are the graphs I made. So these are the graphs of how many files were downloaded per month. And these graphs count the individual files that were downloaded, which were inside the datasets. And they also show the data types of the downloaded files. So the top left graph is for each day of the month, and then bottom right is aggregated over the whole month. So we also looked at the data types of the files because we were looking at whether or not it was worth it to take the time to clean up the raw data sets to make processed data. It's supposed to make the data easier to work with. The hope is that more amateur scientists who don't have like 3 degrees and PhDs and all of that would be able to work with the processed data sets and get more interested in this open science. So we were looking at whether or not it's worth it to take the time to clean up the data sets if it gets more people interested in science. And as you can see, the number for the processed data sets that were downloaded is pretty low for February 2021. So two reasons I could think of for that number being so low is people not downloading it, or it might also be that there's just not that many processed data sets available because it takes time to clean up the raw data sets. So that's something we can look into in the future. And then this is the top 5 most downloaded data sets for February. And originally I was going to include the number of downloads for every single data set that was downloaded, but then this graph would be way too long to ever fit on the slide. So I just limited myself to the top 5 and made it a pretty blue color. And GLDS 243, as you can see, is the most downloaded dataset for February 2021, and that is a metagenomic skin study. So the aim of making this graph was to look at what datasets people like the most. What datasets are they interacting with the most? Which ones do they like to download? And then we can make more studies like that, like with the similar organism to the most downloaded study, or like different assays, or make studies that are more like the studies people like. And then I made the graph because the visual representation of this data is important. Like, it's one thing to tell somebody, like, this is the most downloaded data set, but it's another thing to show them. A picture is worth 1,000 words after all, so hence the graph. And then this is probably my favorite graph, just because it was the most fun to make. This is an IP heat map. That's what I call it. So for each IP that downloaded a data set, we looked at what country did they come from. And I used the IP to GeoTools module in Python to get the country for each IP. And then I used Plotly to make this graph because Matplotlib doesn't have an easy way to make graphs like these. They're called choropleth graphs. I can never pronounce that right. And I want to give a quick thank you to Anna Uriarte, I'm probably mispronouncing that, for helping me make this graph. So the interesting thing about this graph was trying to figure out the color scale. So we made it blue to match the OSDR website, and originally I was using the regular old blues color scale from Plotly. But that made the US and Australia a really dark blue, and you couldn't tell the difference between them, even though they were several thousand downloads apart. And then all the other countries looked near white. They were so pale blue, and you couldn't tell the difference between those either. So this data set that went into this graph was interesting because some countries like the US and Australia had several thousand downloads. Most of the countries had less than 100 though. So I had to figure out how to shift the blues color scale to show the data and the differences between the countries better. So eventually I figured out how to shift the blues color scale so that, as you can see, the countries that have several thousand downloads are much darker than the rest. Countries with less than 100 downloads, you can still see the difference between them. And you can also see the difference between US and Australia because there's a several thousand download difference between those two. And then this is part 2 of my project. Once I finished making the graphs for part 1, I moved on to part 2, which was looking at the statistics and the metrics for the datasets themselves, which I got from the OSDR API. So the OSDR API had the data as in a CSV file as a link online. So I read in the CSV file from that link with the relevant columns for each pie chart. And I looked at like each relevant column. The CSV file had a row for each file in the dataset, which means one dataset would span multiple rows. So I had to make a list of all the GLDS numbers I had already looked at, so I could tell if the GLDS number repeated and showed up again in the subsequent rows, I could skip it because I knew I'd already looked at that study, because I wanted to make sure I didn't double count anything. So, oh, is loading. Interesting. Uh-oh. Tech issues, yay. So I made 5 pie charts from the API data, and these pie charts were made to replace the ones that had been manually made before. So the manually made ones came from manually going through and counting up about 400 of the datasets. And as you can imagine, that takes a while, so the coding is a faster way to do it. I was going to show the spaceflight ground studies pie chart that I made, but apparently the slide isn't working. So it
I know.
showed.
Sorry to jump in. Does the reload button on that slide work? Because that might fix your problem.
Where's the reload button?
The right in the middle of the screen, because that's underlined. I think it might actually be clickable.
Wait. Hmm.
Yeah,
Whoops. Okay. I guess that isn't working. I can go out of the slideshow mode for a minute if that would work.
It's okay. I think just keep moving on.
All right.
You just explain what the slide was showing us. We can keep moving.
Basically, I made a pie chart showing which of the studies in the OSDR API were spaceflight studies or ground studies or high altitude studies. And the high altitude studies were ones that, for example, involved weather balloons or parabolic flight, things like that. And then the second pie chart, which you can see, shows which organisms each of the studies used. Some of the studies had multiple organisms in one study. One interesting thing that came up with this graph is the microbes count is really high. So the manually made pie chart, which this was made to replace, had the microbe count about equal to the rodents count. So we're still looking into whether or not the microbe count is supposed to be that high compared to the others. And then this is the third pie chart. This shows which agencies were working with NASA or funding these studies alongside NASA. So this chart only shows percentages of the international studies. It doesn't include the ones that were just NASA. So the top 3 collaborators are Europe, Japan, and Germany. The fourth pie chart shows which assays were most often used in the studies. This pie chart only shows the omics assays. Since histology isn't technically an omics assay, it might not be supposed to be included in this graph, which is something I have to look into still. And then the fifth one shows the main primary factors that the studies were looking at. So unsurprisingly, spaceflight is the most common primary factor for these studies. And as you can see, other in this graph is a big category, about 45%. So it was tricky finding an easy balance between how many categories to include. Including only the top 5 was too few. This has 10, which might be a little too many. If we include too few, the other category becomes too big. And if you include too many, it looks cluttered. So it was tricky finding a balance between that. So one thing that came up for this was color matching the pie charts. So I tried to, where I could, color match them to the manually made ones. But for some of them, my pie chart had more categories than the manually made graphs. So I had to figure out how to add more colors in, and I had to pick colors that would look good and be visually distinct on the chart. And I had to make sure there were enough colors in the array for the number of categories. Because if I didn't put enough colors, the colors would repeat and my code would break and Python would get mad at me, which is not good. So the impact of this project is we're looking at how to get more people interested in science through looking at the raw and the process data sets. So to hopefully help out amateur scientists who want to get interested in data analysis, in biology, things like that. We were looking at what studies people like and interact with the most, like who's using this data, where are they coming from? So we're trying to figure that out. We're looking at what GeneLab and ALSDA are primarily working on, what organisms, what primary factors are going into their studies, where their time and money is going. And this project helps us to see the details of these open science datasets so we can figure out the impact. Because open science helps make science more accessible to everyone. So I'm glad that the project I was doing helped improve that, and I'm glad I got to be a part of that. So what I enjoyed about this project on a more personal level is this was my first quote unquote real job. And I got to experience the working world for the first time. I got to work on site at NASA, which is the dream. And everyone was very welcoming. I got to have a routine this summer. I got to work on a fun project where I could use my coding skills in the real world. I got to hone my coding logic with interesting problems that didn't necessarily have like one given solution like there is in the classroom. I got to meet so many cool people. So this project was really fun to work on, and I really enjoyed this opportunity. And then I want to thank Brian Scott and Dr. Lauren Sanders for giving me this internship opportunity to work at NASA. And I want to thank Sam Jebre and Danielle Lopez for being my mentors for this project. Thank you.